I'm joined by Associate Professor Paul Tallon, who is the Executive Director of the David D. Lattanzi Center for Information Value at the Selinger School of Business and Management, Loyola University, Maryland. Paul, welcome.
Hi, Katina.
I'm really pleased to see the following supplementary material as an addendum to your paper on big data governance. From what I can see, you've spent some time implementing a number of your approaches to understanding big data storage problems using simple projection models in spreadsheets. That might be a good segue for individuals responsible for data handling to review their current situation. This kind of what-if analysis, by changing a few global variables, may not give you exact projections, but can be used to identify ballpark figures and a way to describe the state of one's data storage issues. When I used to work at Nortel Networks, we often used these kinds of spreadsheets in pre-sale situations as a vendor, but we were also well aware that our clients had similar models to work with in order to ask for specific sets of professional services in the future, or even provide awareness and knowledge for new requests for information and the like. So you've provided us with two projection models. Let's start with the first one, the cost of projection of big data. Can you tell us about it?
Sure. So let me give you a little bit of background as to why I created this model in the first instance. So very many of the conversations that I was having with executives were increasingly collecting more and more data, and we really haven't a good handle on what's this going to do for our cost structure. So what I did was I put together a projection spreadsheet that tries to look at the different issues around collection of data, and then to project forward what might be the subsequent impact on cost structure if, for example, you have a refresh rate or you have perhaps an ability to retain data for longer and longer periods of time. So what exactly will big data do in terms of impacting your cost structure? So the spreadsheet itself, there are 5 assumptions that go into the graph that you see on the left-hand side. The 5 different assumptions, which are highlighted in yellow, can be changed to suit whatever particular instances or situation or circumstances that an organization is facing. So I could, for example, look at cell number N2, which is looking at the annual rate of data growth. And here, all that you simply need to do is to put in a percentage that represents perhaps the number or the rate at which your big data is growing. There's no need for me at this point to kind of look at the different types of big data or where those big data are being stored in terms of the tier infrastructure. That can kind of come later. You can also look at cell N3 and ask yourself, for every dollar that we spend on hardware, how much do we spend on software, and manipulate that number to see what impact it has. Assumption number 3, which is cell reference N4, asks about refresh rates. So ordinarily you might be in an organization where you're looking at a 3-year refresh rate, but what I find is really interesting is when you decide perhaps that you want to refresh your storage infrastructure a lot faster than 3 years, or perhaps to delay it a certain period of time, perhaps from 3 years back to 4 years, what sort of an impact does that have on your cost structure? Assumption number 4 looks at labor costs, because I've seen situations where the overall hardware costs might actually be falling even as you're collecting more and more data, but the labor costs and the licensing costs, and let's think of it as non-hardware costs, are actually growing rapidly, and you might not be in a position to cut back those costs. The final assumption, which is assumption number 5, recognizes that as we're collecting more and more data, we might actually have to build out our footprint within the data center. And as we do that, we might actually have to increase the number of bodies, for example, that we have working in the data center. So across those cell references N2 through N6, those numbers can be manipulated pretty much at will, and you'll be able to see exactly what impact that has on the cost structure. So as the spreadsheet is currently set up, I can see, for example, with a 50% annual rate of data growth, with a ratio of labor of non-hardware to hardware of 7:1, with a 2.2 refresh rate, with 8% annual rate of change in non-hardware costs, and with a 5% impact on labor costs associated with an increase in the volume of storage devices, I can see just by looking at the graph on the left-hand side that my total storage costs will actually grow by about 150% over a 7-year period. That to me suggests that in a situation where a CIO is looking at a very tight budget and perhaps is under pressure to scale back, they may look at those assumptions and say, well, if this is what our organization is asking us to do, there's no way that I'm going to be able to accomplish all of this if my overall costs are projected to grow by 150%. So what they can begin to do with this spreadsheet is to say, if this is the rate that my big data is going to grow by, and you can change the number in cell reference N2 to reflect what you think your annual rate of growth is going to be. If you're then saying to yourself, well, I can't see my overall costs, or I can't allow my overall costs to grow by any more than X% per year, what you actually may be then in the position to do is to play around with the other assumptions. And what you might actually find is that for example, a 60 or a 70% annual rate of data growth, in order to keep my costs under control, I might have to extend my refresh rate from, in cell N4, from, for example, 2.2 years up to 4 years. So what it allows you to do is to see where you can allow some costs to grow, but then you need to scale back those costs in order to keep the overall cost of hardware plus non-hardware under control.
Looking at data as one big chunk, if I was to consider data as a tiered way of describing the data itself, how could that impact data migration issues?
So if I look at a tiered infrastructure where tier 1 is typically the most resilient, the most reliable infrastructure, but it's also perhaps the most expensive, all the way down to tier 3, the lower end of the stack, which is probably the least expensive, but it's also perhaps the least reliable. You can see that costs are accumulated within each of those tiers, depending on the volume of data that you have within each of those tiers. And it's important, I think, to be able to recognize that as you move the data from one tier to another tier, there's perhaps a cost saving associated with that. But at the same time as you're moving data perhaps from tier 1 down to tier 3 in order to avail of a lower price point, what you might inadvertently have actually done is to move very high value data down to a less reliable piece of infrastructure. And in the event that that less reliable piece of infrastructure was to be inaccessible, or if it was to go offline, then you might actually find that the risk commensurate with moving the data from tier 1 to tier 3 has actually increased. So when you think typically of moving data within a tiered infrastructure, as the value of the data changes, you're trying to manage the costs, and perhaps you're moving it up in the tier as value increases or as value drops. You're moving your data from tier 1 down to tier 3. There's not always a direct, simple equation as to whether your costs are rising or your costs are falling. So in a spreadsheet that I've developed, what I've tried to do is to give managers the wherewithal to measure the actual impact on costs, whether there's a cost saving or there's a cost penalty associated with moving the data, but to also recognize that there's a certain risk parameter that you then need to build into your cost saving. So it's perfectly okay with saying if I move, for example, 2 terabytes from tier 2 to tier 1, that is going to cause my costs to rise because I'm spending a lot more money on tier 1 than I would be on tier 2. That's true, but at tier 1, your risk is actually a lot lower. So the risk associated with losing the data on tier 1 is lower than the risk associated with losing the data on tier 2. So although there is a cost associated with moving from tier 2 to tier 1, that cost could actually be scaled back by the reduction in risk associated with moving that data to a more resilient, more reliable piece of infrastructure.
So you've also provided a cost simulation of data migration between tiers spreadsheet I want to make our listeners aware of. If we go to that spreadsheet now, could you take us through it, please?
Sure. So what this spreadsheet shows is a hypothetical 5-tier model. And you can see, for example, I've broken out the tiers beginning on cell B9 all the way down to B13. This model can also be changed if, for example, somebody didn't have 5 tiers, perhaps they had something less than that tiers, maybe from 1 to 3. That's perfectly fine. You can change the model to accommodate a lower number of tiers. The values that the user would need to input would be in column C, you have utilization beginning in cell reference C9 all the way down to cell reference C13. What you would do here is to actually punch in the volume of data that you have within each of those tiers. In column D, cell references D9 down through D13, here's where you actually would put in the cost associated with operating each of those tiers. Once those data points are in there, then the spreadsheet can automatically calculate, for example, the total cost of ownership per gigabyte per tier. And in cell reference A9 down through A13, what I've also done here is to put in a hypothetical risk measure associated with each tier. So I'm assuming for ease of simplicity that cell reference A9 contains a risk measure associated with service level or tier number 1, and I'm putting this in as 100, meaning that it's the most reliable tier. As we go from A9 down through A13, again, what a user perhaps could do here is to put in a risk measure that they would perceive to be associated with each of those tiers. So if they perceive that as they go from tier 1 down through tier 5, that the infrastructure starts to become a lot riskier, then they would scale it back from 100 down to some lower number. What I can also see here is the way that the spreadsheet is laid out. If I go to cell reference E3, I can put in pretty much any number here representing the volume of data that I wish to move. So hypothetically, let's say we wanted to move 2 terabytes, which is 2,000 gigabytes. If I put in 2,000 in cell reference E3, directly below that I'm prompted to enter in the tier that I want to move it from and the tier that I want to move it to. So currently I'm defaulting in cell reference E4. It's moving from tier 2 to cell reference E5, which shows that we're dealing with tier 1. And immediately you can see that the spreadsheet is able to calculate the costs associated with moving that data from tier 2 to tier 1. So in this case here, my costs are actually dropping by $6,329 in cell reference H3. But because there's an impact on risk, the value is actually showing in cell reference H4, which is currently highlighting in red, that the risk-adjusted cost is actually significantly lower than that. What you can also do is, in a hypothetical situation where a data center manager is looking to do multiple exercises where perhaps they have multiple pools of data that they need to move across multiple tiers, they could use this spreadsheet in a sequential manner. So they could look at each of the individual exercises associated with moving a specific volume of data from a specific tier to another tier, and then just simply sequentially run the analysis for each one of those activities. And what they would do in that way is to be able to figure out the overall cost implications, not just of a single move, but of multiple moves where those moves are done back to back. So this spreadsheet, again, is just a cost projection. It's a relatively simple way associated with a data center manager trying to figure out what are the implications, the cost implications associated with moving data from one tier to another tier. This particular spreadsheet, if I was to link it back to the spreadsheet that we had looked at previously around cost projections, what I could actually see here is in a situation where my cost projections are inordinately high and I need a way to try and trim costs back, I could use the second spreadsheet to try to figure out what's the opportunities associated with moving data from one tier to another tier that might actually help me free up some of those costs. So if an organization is thinking to themselves, how can I free up some costs? How can I scale back the amount of money that I'm spending on storage of big data? They could use a spreadsheet like this to be able to just punch in some numbers, specify the volume of data that they want to move, specify the tiers, and see what the implications are for cost. Based on the cost savings that they think they might need to generate, again, they could kind of step back into this and begin to manipulate the reference in cell E3 and ask themselves, how much data do I really think I need to move before I generate specific cost savings?
Thanks for empowering us with these great tools, Paul. I know I'll be very tempted to use them within my own classes. Often I've found in my work life that high-level models worked wonders as triggers for further group brainstorming and brought people together to talk about the real issues behind their woes. But it's provided us enough insight to even build more complex models sitting on top of these with more specific numbers. So we appreciate you sharing these tools that I know will be used by industry as well to explore their data migration and projection issues with respect to big data. And I can see your background in chartered accounting shining through here. So thanks very much for your time, Paul.
You're very welcome.